Hello, everybody. This is Coach Myanmar for AP Pre-Calculus. We're going to cover section 4.6 today. They're broken up into two parts. We'll do the first part, which will be conics, only looking at ellipse and parabolas. And let's just get rocking and rolling here. First thing here, we're going to talk about the ellipse. People call it the ellipses. It's the ellipse. Say it right, or don't say it at all. Here's the basic equation right here, and I'll highlight it. How do I highlight? Oh, this thing right here. I'll highlight in orange. This right here, that is our basic form of an ellipse. It's when it equals 1. We call it a standard form. And you can kind of read through everything on your own. I will talk about it as I do example 1, as I kind of tackle everything that you can see here. What's important to note, though, is, you know what? I'm just going to do number 1, and I'll talk about it there. And I can refer back to everything. But everything is there in that upper box. I think it's easier to go through a problem and graph this. So for example 1, I am not set up yet because I'm not in standard form for this ellipse. So what I'm going to do is I'm going to make this equals 1 on the right-hand side. So I'm going to divide everything by 16. So divide everything by 16. So I'm going to end up getting standard form of x plus 1 squared over 16 plus y minus 1 squared all over 4 equals 1. Okay, so I'm going to go through everything. This is a horizontal ellipse because my x value, underneath the x value, that's a larger. So I'm going to be going further horizontal than I will be going vertical. So this is known as a horizontal ellipse. So in this case up here, my a squared is larger than my b squared. Okay. I'm centered here at the h comma k. So if you notice up here in the formula, h comma k, they're both negative. So in this case, our center is going to be -1. So it's opposite sign, -1 comma 1. So I'm going to plot that point right here, -1, 1. All right. Now, we're going to treat these, the 16 and the 4, almost like a radii, kind of, sort of. For 16, if you take the square root of that, we're going to go left and right 4. So from the center, I'm going to go left and right 4. 1, 2, 3, 4. Put a V there so I know that's the vertice. 1, 2, 3, 4. We only have vertices on the further side. That's what we call them. Okay. And then for co-vertices, we're going to go up and down 2 for y because the square root of 4 is 2. So we're going to go up and down 2 for the y. Those are co-vertices. I'll write CV for co-vertices. And then we can connect everything here. So this is what the ellipse looks like. Okay, kind of, sort of. It's not perfect, but whatever. So now I can pretty much answer almost everything here. I'll do foci later. So this vertices, I've already plotted it so you can clearly see what the vertices are. So the first vertice you want to look at is going to be at -5, comma 1. If you notice, I have the same y value as the center. And what is that? 3, comma 1. All right, so those are the vertices. Co-vertices, those are going to be -1, -1, and -1, comma 3. I'll put a little ampersand there because I did that before with the other one. Kind of jam in that ampersand in there. Okay. Oh, that doesn't look any better. Let me fix this one. There we go. Major axis length is only on the vertices. So how far is it from vertice to vertice? If you can go ahead and count right there, but it's going to be 8. Okay, you can tell I draw this little part right down here. Ooh, highlight again. I draw this little part right down here. That tells me how far I ever go from the center. So if I go 4 left and 4 right, my total length is 8. Same thing with my minor axis. Minor axis is the smaller one. So if I go up 2 and then down 2, that total length here is going to be 4. Okay. Domain and range. You can clearly see that our far left is going to be -5. We include it, and then we go all the way to 3. Range is going to go from -1 up until 3. Okay. Last thing I haven't talked about yet are the foci. The foci always go along the major axis. They always go along the major axis. So for this case, because we are horizontal, the foci are going to go left and right. Now, how do we find that? And it's up here. Foci is going to be represented as C up here. So right here is foci. C squared equals A squared minus B squared, or B squared minus A squared, whatever one's bigger. So since we have A squared larger, we're going to do A squared minus B squared. So for foci, I'll make a little note right here so you know I'm doing foci. So for foci, we're going to do C squared equals 16 minus 4, because the A squared is 16, the B squared is 4. So C squared is 12. So C is root 12. I'm going to use this root 12 to graph it, and then I'll go ahead and simplify it and put it down there on the foci right there. Root 12 is between what two numbers? No one's responding. I wonder why. It's between root 9 and root 16, because we know what root 9 is 3. We know root 16 is 4, so it's between 3 and 4. So I'm going to go between 3 and 4 here. 1, 2, 3, and 4, and put it right there. And then between 3 and 4 over there, I'll label those as F's for foci. Okay. If you're wondering what the heck is the purpose of the foci, if you want to think of it like the solar system, and how, oh boy, I'm going deep on the video here. You'll Google it. Okay. Just an example of it is like orbiting the sun. The sun is a foci. They don't orbit directly around the sun. I think it's not a video now, so I better be right. Pretty sure it's over around a foci. Now, it's not that far away, that foci. The foci that we're orbiting is much closer to the center. I'm going to hit pause to check myself. Hi, me again. I was right. We do orbit. The sun is a foci, so we do orbit. The center is not the sun. Anyway, so there's an idea what the foci is. If you're to take, oh my gosh, this is a video. I can't do this. Maybe I can use this board. Okay. So if I were to take, oh boy, I'm in deep now. If I were to take 2 nails and nail them here and here, okay, and I have this imaginary rubber band. I put the rubber band around the 2 foci, and I started drawing like right here. And the rubber band is going to have its elasticity so that it looks like this. So the rubber band is tight as humanly possible. And then I were to take that rubber band and then put a pencil right there and then just kind of like draw it around, stretch as much as I can. That would make the foci. If that makes no sense, well, I'm great at explaining things. So like that's on you. Google it. Okay. Anyway, all right. Hey, back to foci. That's what that is. Now, real quick, let's reduce this because it looks a little bit prettier if it's reduced. Isn't that just 2 root 3? So all we're going to do to label the foci are we're starting at the center and we're only going right and left. So we're only affecting the -1. So we're going to go -1. I'm going to go right and left over that. I'll just put it all in one coordinate point if you're okay with that. And you didn't say you're not okay with it. So there we go. So the coordinate points, one foci is -1 plus 2 root 3, comma 1. The other one is -1 minus 2 root 3, comma 1. Okay. And there you go. That is the ellipse, which really covers everything up here. And that picture right there covers everything as well. All right. Given the ellipse right there, find the following. Find the standard form, we'll do the center, and we'll do the vertices. So this is pretty whacked out. What we want to do here is to make this into standard form, we have to complete the square. So I'm going to rewrite this and organize my x's together. So I'm going to get 9x squared minus 54x. That's all the x's I have on the left-hand side. Organize all my y's now, plus y squared minus 2y. And I'll throw everything else on the other side. So mine equals -73. So I'm going to throw that 73 there on the other side. So I have my variables on one side, everything else on the other. And I'm going to complete the square 2 times in this line. So you're going to see an xing completing the square, x completing the square, and a y completing the square. So here we go. So when I do the x's, all I'm going to do is I'm going to take out the 9 because I need the a term in front of the x squared to be 1 minus 6x plus blank because I figure out what's in that blank. Okay, if you distribute that 9 back through, you would get 9x squared minus 54x. And then plus, there's nothing to take out from my y's because that's already equals 1. So y squared minus 2y plus, this is a different blank, so I'm going to call it double blank. Okay, equals, and then we still have -73 on this side. And then we're going to add 9 times blank and then plus double blank. Because I have to balance it out. Because I have 9 blanks on the left side, so I need 9 blanks on the right side. And then I have 1 double blank on the left side, so I need 1 double blank on the right side. All right, so what goes in these blanks? Well, cut 6 in half, and you're going to square it. So you're going to get -3 squared, which is 9. So I'm going to put 9 on both sides there. And then cut -2 in half, which is -1 squared, which is just a +1. So put that on both sides. Okay. So on this side over here, I'm going to get -73 plus 81 plus 1, which I believe is 9. So I'm going to get 9. I can do this in one step. X minus 3 squared plus y minus 1 squared equals 9. Standard form, divide everything by 9. So now I'm going to put the answer over here now. X minus 3 squared over 1. I can leave it as over 1. I'm fine with that. Plus, because I matter so much, I'm fine with that. Y minus 1 squared all over 9 equals 1. What's the center? Very good. 3, 1. Vertices. So we're going further out, up and down. Whoa. Why don't you just stop me? No, we're going up and down. 3. And we're going left and right 1. So if I were to real quickly just like plot this over here. So my center's 3, 1, 1, 2, 3, 1. I'm going to go up 3 more. 1, 2, 3. This is my center. And then 1, 1, 2, 3. Vertice. So what are my vertices at? I got 3, 4. We're going up 3 from the 1. And 3, -2, because we're going down from the 1. It's not bad. That's a lot, but practice makes perfect. Well, practice makes mistakes that you then fix to make you pretty close to perfect. Hey, now I'm going to give you the pieces, and we need to find the standard form. For any of these, I always just draw. I think it's the easiest thing. I just do a little sketchy poo here, and then we can figure this thing out. So find the standard form of the ellipse with the center of 2, 1, a vertex 7, 1, and the minor axis is 2 long. So I'm going to quickly sketch over here. So center is 2, 1. Label that as C for center. Vertice is 7, 1, 3, 4, 5, 6, 7. Vertice, so you can clearly tell that since that's a vertice, my x is larger. So I'm going to just real quickly write this out as x minus 2 squared all over. I'm going to just leave it blank. Plus y minus 1 squared all over. Leave it blank equals 1. Okay. So my vertice, I can clearly tell that I'm going right and left. How much units? If I count 1, 2, 3, 4, 5. So I'm going right, left, 5. So my a value is 5. So a squared is 25. And then my minor axis length, I know it's going up and down. So if it's a total of 2, it's going up and down 1 each way. So 1 squared is just 1. So it's not bad. All right, parabola. Okay, so with the parabolas here, again, there's all the pieces inside that box. And I'll kind of just go through everything as we do this. There's 2 types. We're used to the vertical parabola. Really not written in this form. We're used to it in different forms as a y equals with the x squared on the right-hand side. But you do have horizontal parabolas now. I just noticed in my notes that this is, oh boy. Let's fix the notes. This should be an x right here. Oh boy. This should be a y right here. Oh boy. Can't believe I never caught this. Yeah, and this should be an h over here. Oh boy. This is the segment called Fix the Notes. Fix the notes. Fix the notes. Everybody's gotta fix the notes. Why was that never fixed? Anyway, now that that's over, Let's go ahead and go through this, and we're going to graph. Yeah, we're going to go ahead and do example 4 and just graph everything here. First things first, this is not in standard form. I want this to be a x minus something or plus something on the left-hand side, or a y minus plus something on one side. So what I'm going to do here is I'm just going to just subtract 6 on both sides. So I'm going to do that. I'm going to get 2x minus 6 equals 1/4 y minus 1 squared. And I want to keep that x in front of that a 1. So divide everything by 2, like literally every single term by 2. So I'm going to get x minus 3 equals 1/8 y minus 1 squared. Okay, so now my vertex is like my center, but my vertex is 3, 1. And I'm going to draw that out over here. 3, 1, that's my vertex. Label that with a V for vertex. Okay, so let's talk about this focus and this directrix. If you notice right here in my form, I have A is equal to 1/4P. So I'm going to set A, which is 1/8, equal to 1/4P. P is very important for us. All right. No, we're not going to push it. We're just going to find it. So P is 2. Okay. That tells us where our focus is in relationship to the vertex. So it's going to be 2 units. And it's either up, down, left, or right. How to figure that out? We are an x equals equation. So we are either left or right. 1/8 is positive. So we are going to the right. So the focus is 2 units to the right. And I'll put a little F right there for focus. Okay. So what's the coordinate point of the focus? 5, 1. Directrix is the opposite way of the focus, and it's a line. Okay. So since this is a focus is to the right, direction is to the left, so it's going to be a vertical line. And I'll put a D right there for directrix. Okay. The directrix will always sit perpendicular to the tangent of the vertex. Okay. Again, I have all this stuff up here. So if this was an up and down parabola, so up and down, let's go with up. This is an up parabola. The directrix is horizontal below it. If it's a left parabola, it'll sit vertical. So the directrix here is x equals 1. Lattice rectum length is going to be 8, because you just take 4 times p and it's up there. So it's going to be 8. What the heck does that mean? It just means looking at the focus. You're going to go a total length of 8. So 4 in each direction. So 4 there, 4 there, and then we can connect these points as such. And that's how you graph that. Okay. So this part right here that I'm about to highlight in orange. Wow, it's a thick highlighter. Orange represents orange. Wow, my marker's now not working. By marker, I mean stylus. Orange is the LR, lattice rectum. Okay, so there you go. There is everything. Dipping our toe a little bit with the parabola here, but again, just kind of go through everything. I know the parabola can be a little bit confusing, but find the vertex first. Super easy to do. Find your p-value. From there, get your focus. Your focus is always going to open to the right or up or down or left, whatever the equation is, it tells us it's going to happen. Directrix is opposite direction. Lattice rectum is going to be that 4 times p. And then we would use that to represent the distance from the foci going up and down or left and right, just depending if it's a horizontal or vertical parabola. Okay, so now what is the importance of the directrix to the focus? I'll tell you real quick. I'll use the highlighter again. The distance from the directrix to the parabola is the same as the parabola to the focus. So if you notice my green line, that is 2, and the other green line is 2. If I do the same thing for purple here, if I go purple right here, this is 4. Okay. And if you notice that half my lateral rectum is also 4. So, ooh, that's why. Okay. So just kind of giving you ideas. I'll erase that so it's not in the keynotes. So don't look that too confusing there. But there you go. And there's our notes. Make sure that you like and subscribe.